Okay, guys, we're going to continue with our notes from the 7.3 day 2, which is going with your online homework. Remember that for Monday, you should have that worksheet done. So those notes are in Schoology. If you have any questions, make sure you're asking your peers. Or again, I will be at Post Coffee tomorrow, Saturday, which is the 22nd from 2 to at least 3. So come by and see me if you have any questions. But here we are, example 5. So remember, if you weren't here yesterday, or even if you were, we've gone through a few examples, and we also skipped and did example 7. So if you're looking back at the notes, you're going to see that. But here we're looking at example 5 is where we're at. So we're going to do example 5 and 6, and then I'm going to put a couple problems up here that you can do if you just feel like you want some practice. So then the worksheet number 1 is due for Monday. The online homework for 7.3 is due for Tuesday. And then Tuesday, you're going to get your ID worksheet, or not ID, excuse me, equation worksheet number 2. And then your test is going to be calculator part Wednesday, no calculator part Thursday. They're pretty short. Wednesday should take about 15 minutes. Thursday probably won't take much longer than maybe 20, 25 minutes, but you'll get the full time there and you'll be able to ask me questions. Mrs. Love, again, has worked through these problems. She has the answers. She's checked her answers. So please ask her questions. She's asked me questions, so I think she's ready to go. Or you can always email me questions and I can get back in touch with you. So as we look here, this is one where you're going to have to start using your identities a little bit. And some of you asked if you'd be able to use that identities on the test. And I said yes when somebody asked, but I looked back and you're actually not going to be able to do it because the identities that I'm giving you are going to be identities that you were supposed to have memorized. So you can have it out as you're looking here, but want to make sure that we're trying to think through. So when I look at this problem, I see cosine squared and sine squared, but they're subtracted. You might remember that is a double angle, but we're not wanting that because we don't want to have a double angle and a single angle. So really what I want to do is I just want to change cosine squared to be something that's sine squared, or because I have sines everywhere else. So hopefully we can kind of remember that cosine squared is 1 minus sine squared of theta. So then if we write everything else that we have here. So from there, we're going to try to simplify our equation. So we're going to combine like terms. And then from there, we want to I would just try to organize it so that my highest degree is first. Now, I don't like having a negative, so you can either reorganize it and factor a negative out, or I'm just going to move everything to the right side. So if I move everything to the right side, I get a positive 2 sine squared theta, because I would add 2 sine squared theta. I'd have to subtract sine of theta, and then I would also have to subtract 1. So again, if that's kind of confusing to you, then just realize here you could just reorder this. And then essentially I'm just factoring out a negative. So it becomes positive 2, negative sine, and negative 1. And then if you divide by negative 1, that would go away. So what we want to do there is we want to factor. Take my square off, my rectangle off. So if you're thinking, okay, how is she factoring that? Remember that this is the same thing as 2x squared minus x minus 1. So if I want to think about, I know it's got to have to be 2x and x, and I'm going to have 1s. So I got to make sure I'm getting a negative 2. So minus 1 for x minus 1 and 2x plus 1. So that's getting me back to that. So then I'm just replacing the x with the sine of theta. So our first step is we're trying to isolate the trig function. So I'm going to set each of those equal to 0. And then we can kind of work each one independently. So on the left side, I'm going to isolate the trig function. So I'm going to subtract 1 and divide by 2. Again, gotta make sure we're getting that right. So there's my trig function isolated. So to find theta, we're doing inverse sine of negative 1/2. So we're looking for exact values here. So you might think, okay, on the unit circle, inverse sine was in quadrant 1 and quadrant 4. So in quadrant 4, we're down here at negative 30 degrees. which would be negative pi over 6. And we talked a little bit about this yesterday, but negative pi over 6, remember, is the same location as 11 pi over 6. So you can write either one of those. I'm going to use that negative pi over 6 just because that's how we would have said inverse sine. But I also need the other one over here. So you can do 2 pi minus negative pi over 6. So you can, sorry, not 2 pi. Let me back up. It's a little late. So we would do pi minus negative pi over 6 because it's sine, not cosine. And I knew that was wrong because I was looking at, that would have been 13 pi over 6. So that would have not been the right answer. So here we would get 6 pi over 6 and pi over 6, which is 7 pi over 6, which is over here where we expect it to be. So then we can find all solutions by adding 2 pi k. And then we have that one. So then for the next one, we're going to get sine of theta equal to 1. We're going to do inverse sine of 1. So we're going to think, where is sine 1? Well, sine is 1 up here at pi over 2. So theta is going to be equal to pi over 2. And if we do pi minus pi over 2, we're just going to get pi over 2. So plus 2 pi k. So the question, though, says between 0 and 2 pi. So we know negative pi over 6. If we start here, negative pi over 6 isn't going to work. But if we take negative pi over 6 and we add 2 pi, like it says, if k is 1, we're adding 12 pi over 6. So that's 11 pi over 6. Again, this place right here on the unit circle is negative pi over 6. That's going clockwise. It's also 11 pi over 6 if we're going counterclockwise. If we add 2 pi to that, like it says, we're going to be more than 2 pi. We're really close to it already. So then my next answer is just 7 pi over 6. If I add or subtract 2 pi to that, I'm going to be too much. And then we have pi over 2. So again, if we add or subtract 2 pi to that, we're going to be too much. So those are going to be our only 3 answers that we have. So just using that identity there a little bit to work through that problem. Okay, the last new one, we're going to find the solution between 0 and 2 pi. Again, we're going to use exact values when possible. On this particular one, we're not going to be able to get all exact values, and I hope you're going to be able to see that here as we get going. So again, you're going to need to use an identity. So we have secant squared and tangent, so hopefully you're thinking Pythagorean identities. So we talked about how we can find those if we need to, if we don't have them memorized. But secant squared theta is tangent squared plus 1. Tangent squared theta plus 1 plus a tangent of theta equal to 3. Now I'm going to go ahead and subtract the 3 because if I'm going to isolate, I'm going to have to get everything to one side because I have a quadratic. So we're going to have tangent theta, squared theta, excuse me, plus tangent of theta. And then 1 minus 3 would be minus 2. So we're going to factor that. So again, if you need to bring that over here, x squared plus x minus 2. So x plus 2, x minus 1 is how that would factor. So we're going to have the tangent of theta plus 2 and the tangent of theta minus 1. So we set those equal to 0. So we isolate the trig function. So the tangent of theta would be equal to negative 2. So think about how we're going to find tangent. We're going to do, theta. We're going to do inverse tangent of negative 2. So you have to think, have you ever seen negative 2 as a tangent value? Y over x. Is there anywhere on the unit circle where y over x can be negative 2? And that's no. So we're just going to type that into our calculator. We're going to have to be in radian mode. And we would get negative 1.11. Now remember, it's negative, so it should be in quadrant 4, and it's giving us a negative answer out. Remember that tangent has no second answer, and part of the reason for that is because of its period. So we're going to add pi k. So that's going to give us the second answer here in a moment. So there's one of our answers. For the other one, we're going to add 1. So the tangent of theta is 1. So we're going to think, where in the world is y over x equal to 1? And hopefully we can think about that in quadrant 1, right in the middle. So pi over 4. Again, there's no second answer. So we're going to find all answers by adding pi k. And what that's going to do again is we know that tangent is positive 1 over here at 5 pi over 4. Well, if I take pi over 4 and I add pi, or 4 pi over 4, I get 5 pi over 4. They're 180 degrees apart. So we have to find all solutions between 0 and 2 pi. And 2 pi, again, is about 6.28. So we're going to start with negative 1.1. But negative 1.1 is not greater than 0. So we are going to add pi to it. So if we add 3.14 to that, we get about 2.03. We add another 3.14, we get about 5.18. Add it again, we're going to be too much. We're going to be over 6.28. So then we're going to come to pi over 4. That's that first quadrant answer. We're going to add pi to that. We already talked about that's going to give us 5 pi over 4. So again, online, your answers are going to be in these funky brackets. Okay, that's just the way they're going to look. I'm not going to expect that you write those, but that's how your answer would be. That's just considered a solution set. So it's saying that all your values for theta would have to be one of those 4 between 0 and 2 pi. So that's what we have there. So I'm going to just kind of write some answers here, show some work a little bit on a couple problems. If you feel like you want to look at extra problems, I might do 2 here, one with exact values, one without, with decimal approximations. But you definitely have plenty that you can practice online as well. So I hope you guys have a good weekend. Again, come see me at Post Coffee if you have any questions, or send me an email. And looking forward to seeing you guys next week. 12 pi over 12 here is pi, so I'm going to add 12 pi over 12. So that's going to give me 11 pi over 12. So there's an answer. And I'm going to keep adding 12 pi over 12. And remember, 2 pi would be 24 pi over 12. So that's as high as I can go. Then I'm going to try 7 pi over 12. That's going to work. I'm going to keep adding 12 pi over 12, so 19 pi over 12. And if I add it to that, I'm going to be above 24. So there we go on that one. The other one I'm going to do is right here. Remember, for cosine, it's 2 pi minus the first answer. Going to add pi to these until we get to 6.28. So we're going to have 2 for each one. And again, online, for those exact values, it would really be for any of these, but that would just represent solution set. Okay, let me know if you have questions, guys. Have a good weekend.